Hey, thank you. How are you?
Really good. Thank you so much for taking time out of your day.
Sure.
I'm really excited. Unfortunately, both of my group members just got like a last minute scheduling conflict from their club, so
Okay.
they're stuck with me. But
Great. Let's get started. Why don't you tell me a bit about yourself and like how this call came to be and everything?
yeah, so my name's Mia. My full name is Amelia. I go by Mia. I go to Marymount School of New York, and I'm currently in a physics honors class where we are doing kind of projects reaching out to big figures in different areas of physics that we're interested in. And people who kind of might have a diverse amount of like identifiers, especially as an all-girls school.
All
Um,
right.
that
Okay.
kind of
And is
women.
that like a real image behind you? Like, is that the view from your,
Yeah, yeah.
where's the school like exactly? Like what street?
97th in Lexington.
Okay. Right. I go to New York about 3 times a year.
Oh, cool.
Yeah.
Do you like it here?
Pardon me?
Do you like it here?
I do, but only for short blocks of time.
That's true. I can definitely understand that. But yeah, we wanted to kind of research because a lot of the time women are kind of excluded from STEM conversations. So a big part was reaching out to women in STEM, so we can kind of include as an all-girls school, see that side of things, and create a more inclusive space for women and girls.
Great. And one more question. What year are you in right now?
I'm a junior.
A junior. Okay, great. So did you get your college applications done?
Not yet. Not yet. I'm still I just applied to some like pre-college programs, but
Right,
yeah.
because you
So,
apply in your senior year, right? Okay, I forgot.
yeah.
I got confused for a second. Yeah.
But yeah. All right. So if you don't mind, I have a few questions for you.
Sure.
First one, this one's a little bit less formal, but if you were stranded on a desert island, what are three things you would bring with you?
Let's see. Well, I mean, if I could, I would have, and I've got this from a science fiction book I've read. I'd want a portable device with as big memory as possible that was solar chargeable, that had like tons of books and like news articles and encyclopedia, like fiction, nonfiction, just so that I have something to do.
Yeah, for sure. Okay, awesome. So then, so now I have some actual questions. And I just want to let you know our last interview that we did ended up going, I know I said like 10 minutes ended up going over. So if at any point you need
Sure,
to,
that's okay. No, I've got time.
okay, perfect. I just want to make sure
Right.
don't be afraid if you need to go to let me know.
Sure.
Um, but yeah, so what was it that made you want to pursue astronomy and astrophysics in particular?
I always love the night sky. So when you mentioned the desert island, my first thought was, wow, it's going to be so dark and the sky's going to be amazing. And I
Yeah.
almost thought I would bring something astronomy related, but I'm like, no, I know enough to enjoy the night sky. And I just always wondered what was out there. Like, what are all those stars? What is beyond?
Yeah.
And it was just so, it's something that it always stayed with me, even like as a child. It's not like something I thought about every day, but it's always something that fascinated me. Then I went to school and learned math and physics, which I thought physics was really hard. And I definitely struggled at first, but one of the assignments we had in class was we had to measure the force constant of a spring.
Mhm.
Have you done that yet? Like Hooke's law, like how tense the spring is?
We actually just started that today.
Good. Oh, wow. Well, we then had to measure how springy it was.
Mm.
And then we had to find the right equation to shoot it at an angle. We had to figure out what angle do we have to slingshot that, like pull it back and sling it at to go through a giant hole in a wooden board that the teacher held across the room.
Oh, wow.
So a lot of you could probably just do that anyway, right? You sort of eyeball it and like estimate, but we had to do it with the equation
Mm.
and the spring constant. So I was towards the end of the group and mine went in. And I was like, what? I can use an equation and like a measurement to like make a prediction of something that can actually work. It was just astonishing. And so eventually I understood that I could use physics and equations to answer original questions about the not just the world around me, but about astronomy. And I definitely love it so much. But there's one little twist because when I discovered out I can be an astronomer for a job, I was about your age. And I was just like, that's amazing. You can do that for a job. So I rushed home to tell my dad, and he was actually against it, and not for the reasons you expect. He just said, Sarah, you have to get a job and support yourself and not rely on any man. And I
Mm.
was like, wow, okay. Because he didn't think an astronomer could get a job. And I'm sure that's what your parents want for you is to go out there and support yourself. Because in the olden days, whoever you married, that's what dictated your life.
Yeah.
Like he had two sisters, and one sister married rich, one married actually an abusive alcoholic. So she left him. She had two kids under the age of two, no job, no education.
Oh, wow.
So, like, obviously, I'm not here to lecture, but yeah, the general concept was I had to get a job.
Yeah.
And so I couldn't study astronomy initially because I had to do what my dad wanted. And in the end, I was able to get a job and support myself. And he saw that, like, he's not alive now. Well, I'm not giving you like my whole personal life, but
No, but
he
it's
was like,
interesting. It is
yeah,
really
but
interesting.
like by the time I got to MIT, he was just dying. He was literally dying. And he was really proud of me because we're from Canada, but the further away you are from MIT, the bigger it is. So he understood, okay, I'm going to MIT. It's like a great job. And I think he understood I finally, like I was already supporting myself. And so I think he was really happy in the end. But I always loved the sky. And to find something you love doing that you're good at,
Yeah.
that's a win-win. And sometimes you don't, like in high school, you're not exposed to all the different jobs out there.
Mm.
There's a million things going on that you just don't know. So I hope for you and your two coworkers, even though they're not here, can find that.
Yeah, that's really inspiring. Thank you so much for sharing that.
Yeah. So just remember that. Got to get your job and keep your own bank account and stuff.
Yeah. Um, so what challenges did you face? I guess you kind of delved into that a little bit, with your dad, but what challenges did you face in your career as an astronomer, even after you got to MIT?
Let me think. I mean, there's a lot, like
Mm.
how in school you submit a test and you get a grade. There's like constant feedback all the time. Once you get to grad school, it's very open-ended and there's like no feedback
Mm.
and there's like no skills training. It's the weirdest kind of school/job. I mean, we try to do a better job now, but it's definitely a challenge because you're just sort of not getting any feedback and you're just struggling. It's a struggle. I'd say that's one of them. My second one is I'm definitely neurodivergent, although I didn't know till I was older that I'm actually on the autism spectrum. And that was really interesting to find out because, I mean, I'm sure you understand it's hard enough to be in social situations, especially as a teenager. Like, there's just no question that's hard.
Mm.
Uh, Being on the spectrum is like a whole other level, actually.
Mm.
But surprisingly, when I got to MIT, it was really good initially because a lot of people at MIT are on the spectrum. And all of a sudden, like, there's a lot of people like you. And that's really great. But I'd say it's a challenge to interact with people. And I see people who don't have this problem, and it's just a lot easier for them.
Mm.
So I'd say this way to interact. Like you can be really good at what you do, but that's not enough in any job. Like you have to be able to communicate with people and you have to be able to talk in a way that people understand, especially in academia. Like your ideas are what matter. And you have to be gentle with people, like if their ideas going nowhere. And so all of that was like a big learning curve. Yep.
That's really interesting. Thank you.
Yeah.
Mm.
But I
Oh,
think
sorry.
it's fair to say, like, no matter how you're different, because you're trying to do maybe gender diversity or
Mm.
like it's always hard when you're the minority. I think that's maybe how I would summarize it, whatever that means, right?
Exactly. Yeah.
Yeah.
It's really inspiring how you've kind of been able to overcome that in so many ways.
Yeah. Work around.
Mhm. So I've looked into you a little bit and I see that you've done a lot of research on extrasolar planets. What interests you in those in particular?
Well, there's that whole question, where are we from? Are we alone? Every single person on the planet wants to know their own life story, whatever that means. And in this day and age, part of that is wanting to know how our Earth formed and evolved. Where did we come from? Are we alone? And so, yeah, the whole question is, are there planets like Earth out there? And that's why I like exoplanets. And
Mm.
also, I just like new things. And I worked when I was a graduate student doing my PhD. Excuse me, I needed a topic, and exoplanets were first discovered. So what appealed to me about them was that they were brand new, that we had no idea what they were. Like honestly, people expected to find solar system copies, but we haven't found any, and we know thousands of planets around other stars. Solar systems are very hard to find, but instead we're finding like big planets where the Earth should be, like a Jupiter mass planet, or we're finding small planets so close to the star. Their period, the year, the time it takes to go around the star is related to how close they are to the star. And some of these planets have an orbital period, a year, of less than 1 day.
Oh, wow.
Yeah, because the planets that are close to the star and planets that are massive, they're just much easier to find for a variety of reasons.
Yeah.
So it's just a crazy brand new field. I mean, it's not brand new now, but when it was brand new, it's just incredible that we can learn all this stuff far away. That's why I went into it.
Wow, that's really incredible. It's fascinating to me.
Yeah.
Like I was talking about this on another interview, but just the like sheer amount of what's in the universe that we don't know about. And I think it's so
Yeah,
incredible that you're one of the people who is kind of navigating through that
yeah, it's
so many people
definitely
have
fun.
no idea about. Yeah, it's fascinating. Um, so yeah, do you want to talk a little bit? You were talking about kind of how you're looking for almost another Earth. Um,
Mhm.
could you talk a little bit about like your research in that? Because I find that really
Sure, I
interesting.
can give you one really specific example.
Oh, perfect.
So right now we'd like to find an Earth twin, but it's out of reach technologically. What we are doing instead is something a lot easier. We're looking for our cousin. And by cousin, that would be like an Earth-sized planet, but not orbiting a sun-like star, orbiting a much, much smaller star. We call them red dwarf stars. They can be 10% to 50% the size of our sun. They're incredibly common. And everything's about ratios because right now we can't see the planet directly. We just see it like the star that's right beside it is always bigger and brighter and more massive. So the smaller that contaminating star is, the better. So we're stuck with these small stars right now. And the main way we observe the planet and study their atmosphere is for planets that go in front of the star as seen from the telescope. We call them transiting planets.
Mm.
So we don't see the planet, we just see the star, and we see the starlight dim by the tiniest amount when the planet goes in front of it. And each orbit, we see that same drop in brightness. But as the planet goes in front of the star, some of the starlight shines through the atmosphere. And just like shining a flashlight through a fog, some light makes it through, some doesn't. And by looking at the star by itself, then the star when the planet's in front of it, we can tell what's in the planet atmosphere by the atmosphere getting imprinted on the starlight. Yeah, I actually invented that idea a long time ago. And it's the main way we observe atmospheres today. So that's how we want to study their atmospheres. We want to look for water vapor, which would mean the planets have liquid water, which would be a really big deal because all life as we know it needs liquid water. And if we can find a small rocky planet with water, it should mean there's a water ocean. Now I'm going to tell you what I'm working on, okay?
Yeah.
So this idea is all great. It's all like fun and good. And we have a new telescope, the James Webb Space Telescope, that's
Mm.
successfully in operation. But now we have a huge problem that we kind of anticipated, but we didn't know how bad it would be. And that is that background star, these M dwarf stars. They're very active. They have a lot of star spots, and these star spots are evolving with time. And those spots create contamination. And they change like the starlight, and also the star's rotating. So it looks a little bit different every time you look at it. And those contamination from the star, right now, unfortunately, it's bigger than the planet atmosphere features or the same size. So what I'm working on now, and this is like cutting edge, you wouldn't get this from reading anything probably. We have to figure out how to get rid of that star contamination.
Oh, wow.
Yeah, that's what I'm working on.
Yeah, that's incredible.
Yeah.
That is so fascinating to me.
Yeah. So it's just like everything. You start one thing and it seems straightforward, then you get a problem and another problem and try to solve it.
Yeah. I think it's just so incredible that you're at the front line of that. That is amazing.
Thank
'Cause I have been back and forth a little bit about what I want to go into, but astronomy has definitely been something that I've been interested in studying. And so to be able to talk with someone who's like at the forefront of that on the front line, I think that's incredible. And congratulations on the fact that you like invented
you.
that they use today. That's amazing.
Well, when you go to college, you can take a class. Um, you know, like astronomy is something you do later. Like you study the fundamentals, math and physics, and astronomy is like applied, but you could always take a class or try to get a project on it and see if it's for you.
Yeah, awesome.
Yeah,
So I have one final question,
sure,
and
of
this is more like kind of again about the social aspect of it.
course.
You touched on this a little bit, but because women are and girls are often excluded from conversations around
Yeah.
physics and STEM in general, what advice would you give to young women, kind of my age in high school, still figuring things out, who might be interested in science or astronomy?
I do have some really important advice. One of them is you need to build confidence,
Mm,
okay? Because women especially have no confidence.
yeah,
And everyone has no all women have it. I'm actually working on that separately, but you need to find a way to build confidence and have peers who believe in you. And you
yeah,
have to believe in yourself, okay? So that's really important. I didn't give you how to do that. I just said it's important to do that. But the way to do it is reflect on your accomplishments. It's like, you know how we're so hard on ourselves? Like, you're like, oh my God, I'm having a bad hair day. But whenever you say, oh my God, I'm having a great hair day,
Yeah.
Like you have to
I
say
love-
those good things. Well, you have to do it. I want you to start. Like,
I definitely will. That's really great advice. I
and
never,
I just got my hair all cut. I used to have long hair like yours, even longer, and I just got it all cut, and I love my new haircut.
it looks
See,
really,
like who says that, right? Like you don't have to say this to other people. It's just for yourself.
yeah.
Or like if you do well on a test, how often do you say, wow, I kicked ass? And how often do you say, oh my God, I'm so dumb. I like got 1 point off.
Yeah.
So you've got to do more of the positive than the negative because the other people are going to do the negative for you. They're going to chip away at your confidence. So you've got to have a way to be confident on the inside.
Yeah.
You do that by be sure to like celebrate your accomplishments and reflect like daily on did a good job. I was a good friend. I'm like proud of myself because I got the job done. That's one thing. The second thing, what is I learned by mistake, which is really helpful. When you do get, it's very much like apprenticeship. So when you do get a mentor,
Mhm.
excuse me, it's probably male or female, but especially a male mentor. The ones who are really helpful are the ones who have grown up daughters because they'll see you as kind of a daughter and they'll want you to succeed. So they sort of have less of a problem because just like my dad, remember I was telling you about my dad?
Yeah.
Like he wanted me to succeed genuinely, wanted me to go out in the world and like do well and like, I just discovered it almost by mistake, but they have respect because they want their daughter to succeed and they can't help but I mean they're not going to like adopt you like a daughter, but we have to put you into a category. So we're going to be like, yeah, I just found those were really good mentors. They just had less hang up.
Yeah. That's really interesting.
Yeah. We'll
I'm gonna,
just try to be thoughtful about the social, like you are now. Like when you go through the world, be thoughtful about the social aspects.
mhm. So I'm writing that down.
Okay.
Yeah. I mean, that was all the questions I had. So if you're in a rush, I don't know. You're totally welcome.
Well, I probably should get going, but I think you've got it. I think just by asking the questions and thinking through things carefully, I think you're going to do well. And I want to give you the astronomer's blessing for good luck, which is I wish you clear skies.
I love that. I've never heard that before.
Yeah, of
I'm gonna start using that if you don't mind.
course.
All
Yes.
right. Well, thank you so much for taking the time out of your day. It's been like really insightful and just kind of inspiring to talk to you because I would love to see myself kind of in your shoes one day.
Well, you
Uh,
should definitely see that. You should vision yourself being successful at your chosen career.
and so just thank you so much.
You're welcome. Bye.
Bye. Have a nice day.